Hello there. I hope all of you are feeling good. Today, we are going to study solving quadratic equations by factoring. Solving quadratic equations by factoring. Okay, guys, this is the topic we are going to work on it. First of all, we should know what is a quadratic equation. Any equation in form of ax squared plus bx plus c is a quadratic equation. This is a quadratic equation. To solve this type of equations by factoring, first of all, I'm going to divide these equations to two groups. The first group can be incomplete quadratic equations. Okay, guys, as you see, any quadratic equation in its left side includes three terms. If at least one or two of these terms are not available in a quadratic equation, that can be considered an incomplete quadratic equation. But pay attention that the first term should be available. A can't be zero. Therefore, the incomplete quadratic equations themselves can be divided in three groups. The first group are these equations: ax squared plus bx equals 0. In these equations, the constant term, this c, this one, is not available, or that is 0. Therefore, the first group of incomplete quadratic equations include quadratic term and linear term, but they don't include their constant terms. The best way to solve this type of quadratic equations is factoring out of x, then using zero product property. Okay, guys. Now I'm going to introduce the second type of incomplete quadratic equations. The second type is ax squared plus c equals 0. As you see, this equation is a quadratic equation in which the linear term, I mean here, is not available, or the coefficient of b in that is 0. Okay, now we are going to find a way to solve this one. I'm going to say the best way to solve this type of equations is isolating x squared and then taking square root from both sides. Taking square root from both sides. And the third type of quadratic equations, they can be considered as incomplete quadratic equations, are equations in form of ax squared equals 0. As you see, in these quadratic equations, the constant term and also the linear term is not available, or let me say in them C and B are zero. And this type of quadratic equations have an obvious solution of x equals 0. Therefore, there is no need to solve this type of equations. This type of equations has obvious solution of x equals 0. Now, we are going to know how can we solve this type of equations, equation from type 1 and type 2 indeed. Let me give some examples. Example, solve. As the first example, I'm going to write this equation. Number 1, 2x squared plus 8x equals 0. As you see, this is a quadratic equation in standard form because the right side is equal to 0 and the left side terms are in standard form. And in this quadratic equation, c or the constant is 0. Then this is a quadratic, then this is an incomplete quadratic equations from first type. As I told above, to solve this one, the best way is factoring out of x or the variable. If we factor out of x, we can have inside parentheses 2x plus 8 equals to 0. As you see, product of two factors is equal to 0. The first factor is x and the second factor is this parentheses. Zero product property says when product of two or more factors equals 0, at least one of them is equal to 0. Therefore, in here, using zero product property, we can claim the first factor, which is x, is equal to 0, or the second factor, which is equal to 2x plus 8, should be equal to 0. This one is a solution or a root because x is alone. And in this equation, we have to isolate x and find the solution. Then we have to solve this one. To solve this equation, you can move this 8 to the right side and its sign will change to negative. Dividing both sides by 2 will result in x is equal to negative 8 over 2 or negative 4. And as you see, we got two solutions, x equals 0 and x equals to negative 4. As the second equation, I'm going to write this equation. 3x squared equals to 9x. Guys, as you see in here, we have encountered with a quadratic equation which is not in standard form. If you want to solve an equation using factoring method, first of all, you should turn the equation to the standard form. You should have all the terms in the left side. Then let me write this equation in a standard form. First, 3x squared minus 9x equals 0 is the standard form of this equation. And as you see, this is an incomplete quadratic equation in which the constant term is 0. Therefore, to solve this one, we can factor out of x first. If we factor out of x, we will have x times parentheses 3x minus 9 equals 0. And now, as you see, we have two factors. Their multiplication has become 0. Therefore, using zero product properties, we can conclude the first factor is equal to 0. X, or the first factor, equals 0. Or the second factor is 3x minus 9. Or the second factor is equal to 0. 3x minus 9 equals 0. This one here, x equals 0, is the solution because x is alone. And in here, we have to solve this linear equation. To solve the linear equation, you can move negative 9 to the other side to reach to 3x equals to 9. And from here, by dividing both sides of equation by 3, the coefficient of x, you can reach to x equals 9 over 3, which will be 3. And as you see, we got two solutions of x equals 0 and x equals 3. The method I used here is the best way to solve this type of incomplete equations. Now, I'm going to solve an equation from the other type, number 3. Suppose this equation is given x squared minus 4 equals 0. As you see, this is a quadratic equation which includes two terms, less than three terms. Then this is an incomplete quadratic equation. And as you see, in this one, the constant term and the quadratic term are available, but the linear term or the term includes x is not available. Then this one is an incomplete quadratic equation from the second type. As I explained above, to solve this type of quadratic equation, it is better to isolate x squared or keep the term includes quadratic in the left side, x squared, and move the others to the right side. X squared equals to 4. Fortunately, in here, you have x squared alone. When you have x squared alone, you can take square root from both sides. Taking a square root from both sides will result in x equals to square root of 4 is plus minus 2. Then you can say we got two solutions which are positive 2 and negative 2. Let me write one more example. Number 4, excuse me. Suppose we have 3x squared minus 75 equals 0. As you see, this is again an incomplete quadratic equation because there are just two terms in the left side. And as you see, in this quadratic equation, the linear term is not available. Since the linear term is not available, to solve this one, first of all, we should isolate the term which includes x2 in the left side. We should keep it into the left side. Then we should keep this term in the left side. Then you can write 3x squared equals, move the other term to the right side, equals to 75. As you see, we have a quadratic term in the left side, but x squared is not alone yet. Then we should have x squared alone. How can we do it? By dividing both sides by 3. If you divide both sides by 3, you will reach to x squared equals to 25. Now x squared is alone, and that is time to take square root from both sides. If you take square root from both sides, you will have x equals positive and negative 5. And you got the solutions. This simple. Let me write one more example. Number 5. Suppose this time we have this example. 2x squared plus 32 equals 0. As you see, this is a quadratic equation in which the linear term is not available, and we are going to solve this equation. Since in this one, the linear term is not available, that is better to isolate the quadratic term and keep it in the left side. Then I want to keep 2x squared in the left side and move this 32 to the right side. Then I got 2x squared equals negative 32. And You can say in here x squared is not alone yet, then let us divide both sides by 2. If you divide both sides by 2, you will reach to x squared equals negative 16. And in here, the students, which are genius, can say any square is positive. And in here, x squared has become equal to a negative number. That is impossible. And from here, straightforward, you can conclude there is no solution, no real solution. There is no real solution. Then, whenever in solving a quadratic equation from in solving an incomplete quadratic equation from the second type, you reach to x squared equals to a negative number, you can straightforward say no real solution. Okay, guys, this much is enough for this session. I hope this will be useful for all you.